Our last speaker before the break this afternoon is Gonzalo Piernavieja. He did degrees in physical sciences in universities in Germany. He's currently the director of the research and development in the Canary Islands Institute of Technology, and today he's going to speak on wind pumped hydro power station for El Hierro Island, and the goal is 100% renewable energy.
Thank you, Paul. Good afternoon to everybody. Before we move from mainland Spain to one of the Spanish archipelagos, namely the Canary Islands, I would like, on behalf of our regional minister for energy, which is my boss, to thank ARN and ASPO, and particularly Pedro, for inviting us to speak about this challenging project. No? So I commented with Pedro that I thought that we would have a bigger Spanish audience, so I would speak in English. The slides are in Spanish, I'm sorry, but there are only a few words. Don't worry about that. So I hope that all of you know where the Canary Islands are. So we are in front of Africa. We are 2 million people, and we face the similar problems as other insular archipelagos that do want to foster renewables, I mean for electricity production, and see that there are obstacles. In our case, there are 2 obstacles that hinder massive deployment of renewables. It's the lack of territory, so we don't have too much land, and the electrical limitations for penetrating with renewables into the grids, so grid limitations. So El Hierro is the smallest inhabited island of the Canary Islands archipelago, with only 10,500 inhabitants, and this area. Oh. So. And I'm here because the Cabildo, the insular authority in Canary Islands, we have like the Diputaciones in Spain. Every island has an insular authority, so we have one administration more. In '97. They adopted a sustainability plan in which Cabildo stated that the island wanted energy self-sufficiency. So they wanted to be self-sufficient, and this was stated in '97. In 2000, the island was declared by UNESCO World Biosphere Reserve. Thought it was an important milestone for going on with this mission to be 100% self-sufficient. The current situation, like in the other islands, so we are dependent on almost 100% by external energy imports. Is oil, only oil. So there is a big plan. There is a renewable energy plan in the Canary Islands. We want to have 30% electricity by renewables. This is very ambitious. In 2015, and we want to overcome this big problem, this energy dependency. So the challenge here is energy self-sufficiency. This is a picture of Valverde, it's the capital of the island with 5,000 people. So we want to do that only with renewables. So energy self-sufficiency with renewables, and exactly with a combination of wind and hydro. I repeat again, one of the obstacles is the technical obstacle is a weak electrical grid, and the problem that renewables have, they are intermittent and fluctuating power source, so we have to think about intelligent solutions. But the island offers great opportunities, so there is a very big wind potential. So maybe you know the islands, we have wind farms running on the islands with 4,500 hours or even 5,000 hours world record on Gran Canaria Island. El Hierro is the island with one of the islands with the highest potential, and there is a height of 1,500 meters to the top in a very close space. So this gives lots of opportunities. So the challenge is to massively store big amounts of renewable energy, and this is done by means of what we have called a wind hydro system. It's a reversible hydraulic power station with the difference that we substitute pumping in valley hours with fossil fuels through by wind energy. Okay, so I will show you a picture, a movie of what you want to do that. Oops. Well, I didn't want to. It's a Canarian timple. Huh? So you see there are two reservoirs. One is very close to the current power station. And then we have, this is an artificial one. This is going to be constructed. And then there is an upper reservoir at 700 meters above sea level. It's a natural crater, which is waterproofed. The pipe is buried, no? And the wind farm is there. So you see the machines there. Huh? Okay, so I will stop because it's too loud. So it's a reversible hydraulic station with the difference that we have the wind farm there. We have a 10 megawatt wind farm, and the philosophy is we feed with wind power into the grid, and when the demand is covered, or where the technical limit of feeding power is achieved, the excess available wind power is used to pump water via electricity. It's not direct pumping, via electricity from the lower to the upper reservoir. And when there is lack of wind, we let the water fall down, and we are transforming an intermittent power source like wind energy into a constant and regulated power supply. So we have been thinking about that for now. We have been seriously studying the system for approximately 10 years with the help of it's a joint project between the Cabildo, the Insular Authority, the electric utility that it's operating on the islands is UNELCO, Endesa, and the ITC, our institute. And we have also looked for additional funding to give a worldwide or at least European dimension to the project. We have been studying in the frame of a FP5 project of the European Commission the ways to get 100% renewables, not only with the wind hydropower system, but also applying renewables to transport and so on. So this was done together with other European partners, and the project is already finished, but we have selected the other islands in the world where a similar system could be implemented. So these are the main characteristics of El Hierro. So the electrical power demand is approximately 40 gigawatt hours, so that you have an idea of the dimensions we have there. The current installed diesel power is 12 megawatt, and the peak is 7 megawatt. It's in summer. We have defined this dimension for the overall system. It's a 10 megawatt wind farm, 10 megawatt hydroelectric power station with different turbines, 10 megawatt pumping station with different turbines also. The two reservoirs, 500,000 square meters, the upper one, and 225,000 square meters, the lower one. So no additional diesel gensets will be needed, and the coverage by renewables would be 80% on the first stage. Okay, so when applying photovoltaics and other renewables, the goal is to achieve 100% renewables. So this is what the system will avoid. It's very illustrative to say in the Canary Islands, so we will make, it's 26 tankers that are coming to El Hierro every year. to deliver the oil that's supplying electricity. No? So out of these 26, only 6 or 5 would be needed with the power station in its current version. So this is a real project, it's not paperwork. So this is, I wanted to highlight that. So the project is being promoted by a company, which is a public company. It's, the shares are 60% Cabildo, so the Insular Authority, 30% the utility, and 10% is the government of the Canary Islands through ourselves, through the ITC. And the society, the company has 54 million to spend. So this is the calculations we have done that the system will cost. So all these concursos are the tenders that are being launched. We have been now 1 year. 1 year ago we began launching the different calls for tenders. And so the wind farm is already, the wind farm, it's 17 million euro, it's already given, or adjudicado, I don't know, it's already given, awarded, yeah. The conduction, the pipe is already, is going to be awarded next week, and in 1 month will be the pumping and turbining station. So we hope that, well, depending on the delivery times of the wind machines and the other rest of the electromechanical machines, so we hope to have the system running in 2010. This is a very optimistic date, but we hope to have the system running then. So this is here where I want to make clear it's a project from Spain to the rest of the world. Thank you very much, and I'm open for every question.
One question for Roger.
Thank you kindly. Yes, Roger Bentley. Do you have a prediction on your cents per euro cents per kilowatt hour over a long period? I'd be interested in that number.
Well, this is a very good question. We don't know exactly. We hope we want to. So we are coordinated with the ministry in Spain, which is responsible for the tariffs and so on. So there is a big subvention from IDAE. I forgot to say that. No? IDAE is financing the project because IDAE thinks it's an emblematic, it's a real outstanding project. And what we have done is to collect money in order to make the project economically feasible. So in the Canary Islands currently, we get paid more. The electricity production is subventioned, you know, so the insular systems are more expensive than mainland Spain. And we have made rough calculations about the cost, but it's difficult to give you figures. It's difficult to give you figures. You can make from the 54 million euro and let's say 35 gigawatt hours, you can make your own calculation, but it's not real. It's not a true cost. No? So you know, it's in the Canary Islands, in the insular Spanish systems, we get paid from the ministry by power installed on the island. So each generating group, each generating set gets some cents per kilowatt installed. No? And we want that this project, since we are planning more projects like that on the islands, serves as a reference for tariffication in the future. Sorry for not being so explicit.
Question over there.
Yes, I'd very much like to know the following. Hydraulic turbines, how many, and what's the capacity, all up, or aggregate capacity, and also wind turbines, how many units and what total capacity? And what's the capacity factor that you assume in the project planning?
Well, turbines, I don't remember exactly, but I think there are 5 or 6 turbines. So 1 megawatt size, 1-2 megawatt size per unit. And wind farm is that's already awarded. It's 5 machines, 5 2-megawatt machine from Enercon. And I don't understood very well the capacity.
The reference to capacity factor. I asked that especially because there seems to be a wide range of assumption as to what is a prudent capacity factor assumption for wind turbine energy. Is it 20%, 30%, 40%?
The percent of penetration.
Yeah, the capacity factor, as we call it, at least in North America.
The number of hours working the turbine.
Yeah, you have to make an assumption there based on experience.
It's 4,000, between 3,500 and 4,000 hours.
So 40%, more or
Yeah,
less.
approximately. This is the average we have on the islands.
Yeah.
In windy areas of the islands.
Okay.
Okay. So we have the trade winds. This is the project is not 100% because the trade winds they are blowing from March to September. So we will have 100% penetration by means of wind and hydro from March, April to September. So the diesel power station will, in principle, not be running during summertime.
Yes, thank you. Thank you very much.
Okay, I think we'll finish that then. But Shell has an announcement to make before